we talked about multiplying polynomials, and I showed y'all the box method. We also looked when it was just a monomial times a monomial and for distribution. There was a few different types in those examples that we did. Okay, what we're going to look at today is dividing. Okay, so with dividing, we have to remember our exponent rule from 5.1, the quotient rule. So if you are dividing like bases, and what you are going to do is you can combine them to that base. They keep that same base, and you would subtract the exponent. The exponent from the term on the top minus the exponent from the term on the bottom. Okay, so this was that quotient rule for exponents back from 5.1. Okay, yesterday we were multiplying, so we had to use product rule. Today we're dividing, so we have to use the quotient rule. Okay, so we have to recall this from our previous lessons. Here, just an example of applying that quotient rule. It would look like x to the 6 minus 4, which would then be x squared. Okay, this is how we apply that quotient rule. Now here, if we do this and the top of the fraction's the top of the fraction's exponent is smaller than the bottoms, when you subtract, you get a negative. Now the thing is, we also need to recall our negative exponent rule. Okay, we do not leave negatives in our exponents. So remember, the negative exponent rule says we can move that term, x to the power of -2. We can make it the power of +2 by moving the term within the fraction from top to bottom or bottom to top. Right now, it's not written in a fraction, so it's understood to be automatically just over 1. So right now it's in the top, so we move it to the bottom, and that 2 can become positive. Now there's nothing in front of the x squared, okay? It's an understood 1 left in the numerator. Okay, so we had to recall our quotient rule, and I'm going to put up here our negative exponent rule. So if you have a negative exponent, that can be rewritten as a positive. You move it within the fraction. Okay, so those are the two rules we need to keep in mind, because we do not leave our final answers with negative exponents. All right, so let's try this. In number 1, in all of these, we're using the exponent rules to simplify, and they should all have only positive exponents. That's what we were just saying. So we may have to use this negative exponent rule to rewrite them. So in number 1, I've got a base 8 in both the numerator and denominator. So 8 is my base. And then my exponent on top is 4 minus the exponent on bottom, which is 8. So 4 minus 8 is -4, which we do not keep a negative exponent. So I'm going to rewrite this. The base is now going to be in the denominator. And that -4 power becomes +4. And there's nothing else besides this 8 term. There's no coefficient or no other variable. So it's just an understood 1 in the numerator. Now, because it's a number, up here, these were letters. So we left it as x squared, okay? But this is a number to a power. So when they tell us to simplify, if it's numbers raised to powers, we can go ahead and calculate those, okay? So if I go through this and I do the expanded version, if you need to see it, 8 to the 4th means there are 4 8s being multiplied by each other. Okay. 8 to the 4th, that's what this means. So we need to go ahead. You can't do the 4th power in your 4-function calculator. Okay, so but you can do 8 times 8 is 64, times 8 again is 512, and times 8 again is 4096. All right, let's try number 2. Now in this one, I'm going to group together because it's not just a single value. We've got a no, did not want to highlight all of that. We've got the 25 and the 5 as the coefficient. And then we've got n to the 5th and n as our variables with the like base. So now I'm going to go ahead and divide the 25 over 5, which is just 5. And then I'm going to combine the n would be 5. And then there's no exponent here, so it's an understood 1. So that would be 5 times n to the 4th. No negative exponent, no powers on numbers that I need to simplify. That's as far as we can take it. Okay, that color coding. The 5 came from dividing 25 by 5. And then that came from dividing the n, the base n values. All right, 3 gets a little more complex. So I'm going to do the same color coding. I've got my coefficient of -7 over the coefficient of 28. And then I've got a term. And there's a b term. Well, it's not really letting me be very specific with my highlighting, unfortunately. I'm going to try and get that C a different color because that C, there's no other C to go with it. All right. So the 7 over 28 will reduce. Okay. 7 goes into 28 4 times. So it would be -1 over 4 when you reduce that. Okay, and then the a squared minus 1. Because remember, that's an understood 1 on that a, if nothing's written there. Same thing for the b, that's an understood 1. So it'll be b, and then 3 minus 1. And then there is no c in the numerator, so c is just going to stay in the denominator. Okay, so now let me simplify this sum. In the numerator, that a would just be to the first power. 2 minus 1 is just 1. And the b would be squared. I do not have to write that 1 in front. Multiplying by 1 is understood. Now in the denominator, it's 4c. Now you can have the negative in front of the whole fraction like I did, or if you have it up top in front of the a, that's okay too, just as long as there is a negative there. Okay, so let me color code what we did again here. So I did the 7 over 28 reduced to -1/4. Whoa, just happened. There we go. A is reduced there. In here. And then that C stayed down there by itself because there was no other to C to combine it with. All right, let's try number 4. In number 4, we've got some simplifying in the numerator to do because there's a parentheses with an exponent on them. Okay, so remember back in 5.1, we said that that exponent is outside these parentheses. That means that power of 7 is going to each term inside the parentheses. Okay, so first of all, this negative is an understood -1. Okay, so really there's a -1 getting the power of 7. There's A getting the power of 7. And there's B getting the power of 7. Okay, they all get the power of 7 because they were all in parentheses raised to the power of 7. Now, if you know the rule, you don't have to multiply out -1 times -1 times -1 7 times. Okay, if it is a negative to an odd power, it's going to stay negative. Okay, but if it was a negative to an even power, it would become positive. But this is going to stay negative. So I'm going to keep the negative, and then it's a to the 7th, b to the 7th. Now in my denominator, there was that 6 is not around parentheses. So the negative is not being raised to the 6th power. It's just the a. So that's still just going to stay negative a to the 6th. So negative a to the 6th. So now I'm going to group these. So first of all, the negative divided by the negative is going to come out what? What's a negative divided by a negative? The positive. So we're going to have a positive. So the negatives cancel each other out. Okay. And then for the a terms, we've got a to the 7th over a to the 6th. So that's going to be a to the 7 minus 6. And then b, there is no b to combine it with, so it's just going to stay b to the 7th. And since the negatives reduced, the negatives like eliminated, and that a to the 6th was combined up here, there's nothing in my denominator. It's now an understood 1. So I don't have to write the denominator anymore. So it's just going to be a, because 7 minus 6 is an understood 1, times b to the 7th. Oops. Okay. Let's check out the next one. Now in 5, I see a plus sign here. It is separating the 9y and the 12. So those are two separate terms in the numerator that are both being divided by 3. So that divided by 3 goes to each term in the numerator. When you see that separation with a plus or a minus sign, okay, understand that you are dividing each term that's separated by that plus or minus. Each one is getting divided by the denominator. So you can split that to see it better. These first few, there was no plus or minus between the values. So those were all monomials in the numerators. That's why we didn't do any separating. But here, that plus sign changes this. Okay, so be careful. So 9 divided by 3 is 3, and then the y is still there. And then 12 divided by 3 is 4. And that's as far as we can take that. All right. Same concept here in number 6. There are subtraction signs, just like that addition sign, separating these terms in the numerator. So I'm going to separate them. I'm going to have 27r cubed divided by -9r. minus, and I'm going to have 18r squared divided by negative 9r minus, and then I'm going to have 36r divided by negative 9r. So each of the terms from the numerator is getting the division by the denominator. So I'm going to simplify each of those separately. So in this first quotient here, 27 divided by negative 9 would be negative 3. And then r cubed divided by r, remember that would be r cubed minus 1, 3 minus 1. Okay, then in the second term, it's a minus and we're dividing by a negative. So negative divided by negative, this is going to become positive. It's going to become a plus. And then 18 divided by 9 is 2. And then you've got r squared over r. So you're going to do the 2 minus 1. And then same thing here, minus and then divided by negative. This is going to change to plus positive. And then 3 divided by 9 is 1/3. Oh, that's not a 3. Sorry, I didn't pay attention to the 6 there. That's a 36 divided by 9, which is 4. And then r divided by r, those are both the power of 1, so it's 1 minus 1. Or you may realize without having to write it that way, it's the exact same thing divided by itself. That's going to reduce because 1 minus 1 here, that's 0. This is r to the 0 power. And anything to the 0 power is 1. And you can try that with any value. It doesn't matter if it's a number or a letter. If it's raised to the 0 power, it's just 1. That's one of the rules we learned in 5.1. So you can either show the 1 minus 1 is 0 and then eliminate that, or you can show up here by marking through the r over r, that those are exactly the same in the numerator and the denominator on top and on bottom. And so you can cross through those because it goes away. Okay, so then this is going to become negative 3, and then 3 minus 1 is 2, plus 2, and then 2 minus 1 is just 1, which is understood. And then that'll just be plus 4. The r in this term is gone. And that's as far as we can take it. We can't combine any of those terms because this r is squared. This is a r, and this doesn't have an r at all. So none of those are like terms. I can't combine any of them. Okay, so different types of dividing depending if there's plus or minus signs separating multiple terms in your numerator. Okay, so be careful with these. So I'm going to pass out the practice for this and go over which problem numbers are assigned to you for 5.6. So let me get that passed out to everybody. Y'all move the desks back up where they were, please. These desks in front are all aligned. Move your desk up for me, please. Move the whole row up. Okay, so everybody should have a 5.6. Let me pull it up here. All right, so for 5.6, y'all are assigned to do problems 2, 5, 6. 8, 9, 11. And then if you flip over to the back, you're going to do 13, 16, 18.
No, I heard it.
Okay, now this, today's Tuesday. This isn't due technically till Friday. Friday is your test day. I think you should be able to finish it before then. But if you need the extra time, you can take it. 2. So here's the front again. 2, 5, 6, 8, 9, 11. And the back is 13, 16, 18.